Hi, so in this video, I'm going to talk about chapter 11 atoms, ions and isotopes. So let's start with ions. Just going to go directly define what ions are. Let me just share the screen. Here. Okay, ions. I'm going to write down ions. So as I mentioned earlier, atoms usually comes electrically neutral. That means that we have the atoms usually has a same number of electrons as the number of protons. Number of protons and number of electrons usually match. So plus and minus and same number, and it becomes electrically neutral. But actually, it's pretty easy to remove electrons or add electrons to atom. Here, what you gotta make sure to understand is that it is not proton. Protons are tightly bounded to their nucleus, right? So proton is always in the nucleus. It's not easy to get rid of or to add protons unless you apply a really large amount of force. But electrons that's surrounded around the nucleus as a crowd, it's just really easy to remove or add. So you might sometimes have a deficiency of electrons or excess number of electrons compared to protons. And when the atoms have unbalanced number of electrons compared to protons, then it becomes ions. So ions is a state that electrically charged atoms. So here, let me see, ions. Just write down, define ion. What ion is? Ion is not an atom. Or it could be actually a molecule. We're going to talk about molecule too, but in which the total number of electrons is not equal to the total number of protons. So it has that means that atom. That means atom or molecule. Atoms are molecules with a net electric charge. So that's what it means by ion. Ion has maybe more or less number of electrons compared to the number of protons in nucleus. So again, it is the electron is the one that's doing the job. Let me see. If you have a excess number, so depends on the situation. Positive ion. So here, positive ion. What do you think? Is positive ion has a deficiency or excess of electrons? For the atom to be positively ionized, it's going to be having deficiency. And negative ion. For atom to be negatively ionized, does the ion have excess electrons or deficiency of electrons? It should have an excess. So again, I want you to make sure that it is the electrons, right? Not the protons that's doing the job. And less number of electrons is positively ionized. If you have more number of electrons, and that means that it's negatively ionized. Let's see if so sodium here. Sodium. Let's look at a sodium here. Can you find the sodium? What's the atomic number of sodium? It's at atomic number 11. How many numbers of proton does sodium have? 11. How many number of electrons sodium have? 11. So then there are 11 electrons, 11 protons in nucleus and 11 electrons. Let's see how these electrons are located inside the sodium, right? So first two of electrons in the sodium will sit in the first shell, because the hydrogen, helium. So there are two available seats in the first shell. And then in the second shell, there are 1, 2, 3, 4, 5, 6, 7, 8 seats available for the electrons. So the two electrons sits in the first shell, and then another 8 electrons sits in the second shell. Sodium has total 11 electrons, so only one electron. So total 10 electrons are sitting in the first shell and second shell, filling up all the shells. And the one electron, 11th electron, is sitting on the third shell by itself. By itself, right? And let's look at this periodic table. On the third shell, how many seats of electrons are available on the third shell? Here. 8 seats available, right? There are 8 seats available, but in a case of sodium, only one electron is sitting. So let's see. Example, sodium, atomic number 11. 11 protons, 11 electrons. So let's say we have 11 protons in the middle, and 2 electrons in the first shell. And 1, 7, sorry, it's not so even, but 8 electrons, right? And then on the third shell, there's a 1 electron sitting in the third shell. But the third shell actually has space available for 8 seats available. 1, 2, 3, 7 and 8. So 1 out of 8 is taken on the third shell in the case of sodium, right? Let's look at here. Sodium is 11, so it's only filling up the first. And there are 7 seats available. So in the case of sodium, imagine that there's a most outer shell, there's only 1 electron is sitting by itself. Would it be easier to fill out all the add 7 electrons to make it stable? Or just take off 1 electron so that this atom will look more stable? The electron will be nicely packed. In this case, it'll be easier to remove 1 electron in the third shell, right? So much easier to remove than adding 7 more electrons in it. So when you have 1 less electrons than proton, then the sodium, it's easier to become positive or negative. Removing 1 electron, so it'll be easier to become positive. By how many? 1. Right? Let's see. Oxygen. Oxygen here. What's the atomic number of oxygen? 8. So there are how many numbers of protons? 8. How many numbers of electrons? 8. So 8 protons and electrons. So another example, oxygen. Atomic number 8. So then that means that we have an 8 proton in a nucleus, and first 2 electrons sits in the first shell. And in the second shell, there are 8 spots available, but there are only 6, 2, 3, 4, 5, 6. So total 8, right, electrons. And however, there are 2 more seats available. So in this case, it'll be easier. To remove 6 electrons from the second shell or add 2 electrons to the second shell. Which one would be easier? Adding 2 more electrons is easier than removing 6 electrons, right? So adding 2 more electrons into second shell is easier. So oxygen atom, does it tends to be positively charged or negatively charged? And then would that be by how many? Is it positive 1, positive 2, positive 3, or negative 1, negative 2, negative 3? it's easier to add 2 electrons, so oxygen has a tendency to become 2 minus. So here I want you to note that it's still the same atom. It's the same element because atomic number doesn't change. Number of proton doesn't change. But it is the number of electron that changes and it becomes ionized, means electrically charged. So either it becomes positive or negative, it depends, right? Depends on, and then you can look at, now you understand the periodic table and see where this element that exists. So if that element, let's say, another example, chlorine. Chlorine has atomic number how many? Chlorine has atomic number 17. That means how many numbers proton and how many numbers of electrons does the chlorine have? 17 protons and 17 electrons, right? But you can see chlorine locates second from the right. That means that a chlorine, and then it's on the third row, and then second from the right, right? So the chlorine has the most outer shell of a chlorine is 1, 2, 3, 4. What shell? Chlorine has 3 shells filled with electrons. However, on the most outer shell, the third shell has how many seats available? 1. But filling up all the 7 seats, right? The seven seats are taken by electrons and 1 seat available in the most outer shell and the third shell. So in the case of a chlorine, was that going to be positive or negative? That's right, chlorine tends to be negative. By how many? 1, because it has only 1 spot. So you can see where the element locates in the periodic table. Is it going to be positive or negative? Does the element change? No, it's still the same atom. However, it becomes ionized, means either you have an excess amount of electrons or deficiency of electrons. It doesn't mean it changes characteristic. It's going to be electrically charged. By how much? You're going to look at the periodic table. What happened to those inert gas? The most right column, helium, neon, argon, krypton, and xenon, radon. What happened to them? These most right column always have the electrons filled up all the way on the most outer shell. So they don't have any seats available. They're just nicely packed and they're very, very stable. Therefore, they're not going to be ionized. They're not going to be ionized. They're not going to be easy to be ionized. It cannot be ionized. It's not easy to add or take off the electrons. So helium, neon, argon, krypton, inert gas won't become ionized as easily. So that's the idea. Okay, so that's the ion definition of ion. Isotopes. Isotopes, definition of isotopes. So you hear the word isotopes, you get scared. You might always think about radioactive. It's not necessarily. Make sure about the isotope. Isotopes means it has a different, isotope has a different number. So I talked about different number of electrons. Now I'm going to talk about different number of neutrons. But again, the number of protons do not change. So that means that it's the same element, right? So same number, protons and electrons. Let me stop for a moment. Maybe I'm going to talk about isotopes in a different video. So it's getting a little bit long. So I'll talk about isotopes in a different video. See you then.